So we got these two theorems. You have to know this. What's that? 12. All right, here we go.
Oh.
Gotta get write it down.
Evaluate. A limit at infinity, folks. We've got to find the horizontal asymptote. Okay. You have to be able to find the horizontal asymptote. You're going to see me write it HA. Okay. VA is vertical asymptote, and HA is the horizontal asymptote.
Did you know the carnival season is started yesterday?
The what?
Carnival season.
Carnival season?
You know the stuff from Rio?
What?
From Rio.
From Rio in Brazil? Okay.
What they do?
Is Carnival for a religious thing, or is it a...
I'm actually not sure. Like, it's at our Catholic town, and all the Catholics are doing it.
Oh, it's like.
I'm not sure. It has to do something with religion.
All right.
Actually, everyone's doing it.
Everybody's not, because I'm not.
Yeah, well,
Mexicans don't make
it's just you just do the first day, you dress up, and the teachers, they bring like this special kind of cake for students, and you say like, you know, instead of pie.
Okay, just shut up.
And the last 3 days,
I still got the first pie.
you go party, like clubbing. It's in one city, and every club is like open and you dress up like.
Oh, so Catholic people go to the club.
It's
After the
funny.
Jesus
Like, they're doing, you know, paper.
That's on Tuesday,
Yeah.
Okay. No, we don't really celebrate Carnival here.
Yeah, I heard.
It's fun to say. Carnival. Pardon me?
We actually say Flushing.
Fasching?
I speak German.
All right, here we go. This is what we're going to do. Well, I'm glad you shared that with us because that's awesome. You're going to visit the share party, all the clubbing with the Catholics.
I don't do all the Catholics.
You don't?
No.
Your friends.
Yeah, it's funny.
Is that not allowed to go clubbing with the Catholics?
It is a lot. Like, it's not just the Catholics.
Clubbing with the
Everyone's doing it, but
Everybody's doing it.
it's like in this Catholic town.
I know.
It's just all Catholic.
Everybody's doing it.
Yeah, all Catholic. Everyone is Catholic.
Oh,
And they have
This is in Germany?
it's right in this.
Oh, I bet they wear hot pants too, don't they?
No. We wear costumes.
Costumes.
Yeah.
Man, I gotta see
Is
this.
it like a Halloween costume?
I gotta go. Is the Pope doing it?
It's kind of like Halloween. It's just a creepy. It's funny and
The Pope ain't going to no club.
it's a bedroom.
I mean, they say it's a Catholic thing.
All right, here we go. Check this out. So, look what it says. It says we have to, pardon. We have to divide each term by the highest power of x that appears in the denominator. Okay? Now, the highest power in the denominator is 2. So we're going to take each of these terms and we're going to rewrite it. The limit is x approaches infinity. This is the clue because x is approaching infinity. This is when you do this. We're going to take x divided by x squared over 1 over x squared
Yeah, this means that Allison.
plus x squared over x squared. Okay? No, just look what it says though. In order to evaluate the limit at infinity, this is the only time we can do this. We are really only finding the horizontal asymptote. Okay? Now,
Oh, I get it.
when you see this, That means in your head, you've got to click and go, oh, this is when I divide by the highest power that's in the denominator. So the highest power in the denominator is 2. So I'm going to take each term in that rational function, and I'm dividing each term by x squared. So I have the numerator x divided by x squared. In the denominator, 1 divided by x squared plus x squared divided by x squared. Everything, every single term in the rational function is divided by x squared. You with me that much? Okay? Now, we're going to simplify this. Remember the 2 theorems on the last page? All right, if I simplify these, that would leave me 1 over x, wouldn't it?
Yeah.
X divided by x squared is 1 over x. 1 over x squared plus what? What's x squared divided by x squared? Isn't that x squared on the bottom? Okay, then I'm going to cancel those out and I'll leave 1 over x. All I'm doing is divide. Okay? That's okay. I'm glad you asked. Now, folks, here's what you're going to think. Now, I'm going to tell you why it is, but we will only do this problem this way. Okay? We are, in essence, taking the limit of each piece. And I want this will be the only time you write this. This is the only time you're going to write this. But if you go back and you look at the theorem that you wrote from, what, 2 slides prior, or maybe 1 slide prior. Does everybody have that?
Yeah.
Let's go back and look at that just a second. If I have any number over x, as x approaches infinity, what's it equal to?
0.
0. So, what does my numerator become? I have any number over x as x approaches infinity. What's the limit of that? 0. What's this down here? The limit of 1 over x squared as x approaches infinity. According to that theorem, it's 0. What is the limit as x approaches infinity of 1?
1.
It's 1. Because I don't have anything to plug into. So remember, the limit of a constant is itself. And I'm going to show you the shortcut way here in just a second. Folks, 0 divided by 1, what's the limit of this function right here? 0 divided by 1 is 0. Okay? Now, I went step by step. I am never again going to write the limit of the numerator over the limit plus the limit. I ain't writing none of that anymore. I'm going to show you what we're going to do. But I want you to understand where it came from. What allows us to be able to do that? That theorem 410 says any number divided by x to a positive power, the limit of that is equal to 0.
What is the numerator?
Pardon?
What is the numerator? No,
Say what?
I know that.
Go back.
Like, alright.
It could be any number. It could be a 4. It could be an 8.
Yeah, something like what if x in the positive power was in the numerator instead of the denominator?
Then I couldn't use that there.
Would that be like vertical stuff?
Maybe. But we just have to look at the function that we're given. Okay? Now, that's a whole lot of work for this, for 0, right?
Yeah.
But check this one out. Never again is it going to be this hard. Okay?
Look at the powers.
Look at the powers.
1
What is the
or
thing?
1 negative 1.
Not
What is that thing that you were telling KJ about? That's the.
Hold on. We're getting there. Hold your taters just a little bit. Hold on. You got this. What, are you writing today?
Yeah. Right now. I'm starting right now. Do we always have to write the?
That limit out like we had to? No. Mm-mm. It's about to get really easy.
Yeah.
We still got to do it this way one time. Okay? I'm not gonna write the limit, over the limit plus the limit minus the limit. We're not doing that anymore. But we are gonna do it this way.
Should we put that first?
Nope. What's the highest? All right, now, what's the clue? Nope. X approaches infinity. That's the clue. Okay, so that means, all right, I gotta divide by the highest power. What's in the denominator? What's the highest power in the denominator? X squared, right?
Yeah.
Okay, so here we go. 2 divided by x squared minus 3x over x squared plus x squared over x squared. 7 over x squared plus 4x minus x squared minus 5x squared over x squared, right? Write it down. Write it down. On paper, not in the air. Or in your mind.
X squared over X squared is 1.
Pardon me?
X squared over X squared is 1.
X squared over x squared is 1. What about 2 over x squared? Is it already simplified? It's already simplified, isn't it? Minus
3x.
3 over x, because x and x, right? X squared divided by x squared is 1. 7 over x squared, can I do anything with that? No, I can't do anything with that. 4 over x minus, do you guys agree with that? Okay, now here's where, the next step, if you look at your last example, this is when we found the limit of the first term minus the limit of the second term plus the limit of the last term, right? We're not doing that. This is what we're going to do. If I find the limit of 2 over x squared, what's it going to be equal to? Any number over x to a power will be equal to what? 0. What's the limit of 3 over x? 0. What's the limit of 1? 1. What's the limit of 7 over x squared? Plus minus 5. Simplify that, y'all. What's 0 minus 0 plus 1? What's 0 plus 0 minus 5? Negative 5. You know where this is headed. Okay? What's the limit of all that stuff as x approaches infinity? See a connection there? See what? Hold on. No. Get leave everything. I'm just jealous. Get on out of here. You guys agree? Yes, or maybe?
Yes. So is
that
that the final horizontal asymptote?
That's how. What would the horizontal asymptote be? Negative 1/5.
So I'll have to look at none of those about what my square. So,
You'll remember this from Algebra 2. Okay? You should remember this from Algebra 2. Or you should remember this from Tree last year. Okay? Now,
Didn't have to. I didn't say that. That was ugly.
I want this page, I just want you to reference this in your notes. This is from page 243 in your book. 243, example 5, has to do with trig examples. They don't come up a lot, but it all goes back to, can you tell which theorem this is representing it here?
No.
When you have 2 theorems on the outside and 1 in between. It was a theorem we went over last week. Had a weird name. The blank theorem. Nope. Weirder than that. I mean, they agree that's normal anymore. If you have 2 theorems on the outside with 1 in the middle, and you find the limit because they all match at one spot. What am I doing? Right here.
Squeezing.
What theorem? The squeeze theorem. This is an example of how the squeeze theorem is applied, is what it has to do with this trig stuff. But just reference this to go back and look at your trig examples on page 243 in example 5 to know how much you studied. but I'm not going over that. Okay, now, here's the part that you should remember from Algebra 2. Infinity and negative infinity, positive and negative, indicate growth without bound. I hope you're writing this down, because if you're not working as hard as I am, and I do not understand. And if it's growing without bound, that can't even be a real number. If I can't put my hands on it, it's not a real number. Okay? Positive and negative infinity indicate growth without bound. It's not a real number. Okay? When you have a rational function, I should have put that first, just like I did right here with the radical. They occur wherever we have put constraints on the domain. And you know that eventually all this stuff goes back to domain, right? I can tell that you do. You're pondering that right now. But if you see a rational function, of course, you're going to set the denominator equal to 0. We did that all class yesterday. What's a rational function look like? It's a fraction. Okay, it just looks like a fraction. You know, when we found the domain of a radical, we would take the stuff is greater than or equal to 0, didn't we?
Yep.
And whenever I had a rational function with a radical in the denominator, then we took the stuff is greater than 0 to find the domain, correct? Negative greater. Okay.
If it's in
The denominator,
then it's just for you.
that's good. I want to use that, negative greater. I know you did. I just had to click. So it all goes back to domain, finding domain. Okay? Vertical asymptotes. I don't know if you remember this, and I don't know if I taught it in this class or it could have been first block. But whenever we would write domain, I would think diva, domain is vertical asymptote, diva, right? Did I go over that in here?
Miss Morris will do that.
I didn't go over that in here. Try this in first block. All right, does everybody have this? All right, vertical asymptotes are tied to the domain. Horizontal asymptotes steer the function. It's either going to get really, really, really big or really, really, really small. So really big numbers or really small numbers, meaning it's approaching positive infinity or negative infinity. Okay? Oh, and this must have been where I stopped.
What are you? And I got up there. And I was going to do it, and then she would quit talking to their mind. And so,
That was rude.
I
Can't hear you, can you?
just got mad. I said,
Did you throw a temper tantrum?
No, I was just irritated, is all. I think Evan got up there.
Ooh,
He started screaming at us. Because she told everyone that they were speaking up. I thought I was speaking pretty well.
He was pretty loud. He was like,
Two roads.
And then Evan, he started
It was
screaming.
deep.
Awesome.
He said, too soon.
I hope I
That's
have
fabulous.
her one day. Didn't you say she was pink flip flops with jeans and a dress?
Yeah, she was.
Y'all, the recording,
KJ, KJ, you
Well,
said.
all day.
the recording is leading me to explain to you. It just told me with my phablet that when you have, let's see here. Remember, in Algebra 2, this is what we did. Let me just put it right here. Here we go. Let's think about this. We're going to look at the degree of the numerator versus denominator. Okay, Earlier, we were evaluating as x approaches infinity. We had to look at the highest degree in the denominator. And then we went through and we divided every term by that. So we could use that theorem 410, okay? We are going to look at the degree of the numerator versus the denominator. Now, here's my thing. If the denominator is bigger, if the degree is bigger on the bottom, what did I tell you last year? Remember, if it's bigger on the bottom, what did guys say?
Yo.
Yo! The asymptote is y equals 0, y'all. You see yo? Y'all don't get it. Do you get it? Guys are looking at a bunch of girls, and girls are bigger on the bottom. The guys, they all look together, they go, yo! Yo! Like, look at yonder at all that booty.
That's all booty.
Look at all that junk in that trunk.
You heard that in the song whisper? It says, how do you fit all of that into those jeans?
No, I have not heard that song. Here's so, if it's bigger on the bottom, yo. If it's, excuse me,
No. You're doing top, no.
if it's bigger on top, if the degree is bigger on top, I'm telling you as a mother, check this out. No.
No.
No, there is no horizontal asymptote. Okay? It's bigger
Why
on.
did you say as a lover?
I don't want fellas looking at my daughter that way.
But if those on the bottom, it's okay.
No. Just memorize it. If the degree is equal in the numerator and the denominator,
It's never okay.
it's the ratio of the leading coefficients. And I'm going to abbreviate that, coefficients, okay? And that's what Amarius was trying to get y'all to see on that last example. When you get that, I'll go back and let you look at it. And I told her to get out. I was like, no, I haven't got it yet. Get out. Okay?
Well, why don't you show us on this?
Because I have to. The degree is 2. The degree is 2. What are all
Leading coefficient,
the leading coefficients?
1 and 5.
1 and 5, negative 1/5. Boom.
Oh.
Shut the front door. This is how we get those little tiny easy rules. Okay? So look at this next example. All right, we got these rules from Algebra 2. If we had, okay, determine the horizontal asymptotes if they exist. I don't know. I've been waiting to say that. I've been waiting to say that to teenagers.
I know, there's the yo and then.
Right, okay. I did it. That was my fault. To determine the horizontal asymptotes if they exist of the following functions. Determine the horizontal asymptotes if they exist of the following functions. If I gave you this function, I want you to write this down. Don't say anything out loud.
I feel like I'm in charge.
I'm sorry. I shouldn't. That so needs to be said to your generation. It does.
We didn't have an incentive.
I just wanted to say amen.
If there's things to tell you.
No.
It's very,
No.
you should want to simple, you should say it.
No.
Everybody.
That's what I said.
I'm just repeating what's done something.
Oh.
La 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 la.
There you go.
Here we go, here we go, here we go.
I did it, please.
What the bar were you up to?
Check that out right there.
You did it.
Check that out right here.
Put it right there.
And I'm fixing chicken home.
Everybody does it.
Everybody.
Seniors do it.
How about the, he didn't say, yeah. Senior citizens always want to do
They
this.
cheat.
Yeah, they do. All right, so what about this one on the top, on part A? What is this? What's the degree on the top? What's the degree on the
No.
numerator?
No.
What's the degree of the numerator? So a degree of 2 over a degree of who?
3.
So it's bigger on
No,
Bye.
zero.
No, asymptotes.
the,
It's zero.
it's 0. It's bigger on the bottom?
Yo.
Yo,
Yo.
that's the horizontal asymptote.
So you can give me the hot screen.
And I'm gonna know what you're talking about.
Exactly.
And I'm coming down, no!
What's the degree of the numerator for B? How many of you had y equals 0 for the first one? Awesome, good. Question? Or yes, I had degree.
Yes, I had.
Good. What was the degree for B on the numerator? No. Thank you. The degree in the numerator is 2. What's the degree in the denominator? 2. They're equal, so the horizontal asymptote is?
1, 2, 1.
Oh,
Half, 5.
the horizontal asymptote is? Y equals 2/5. Remember, it's a line, so you need y equals 2/5.
That's why I said.
I know. All right, what's this next one? What's the degree of this one? Nope, what's the degree?
3.
What's the degree of the denominator?
No.
Bigger on top?
It depends on where she.
Is none. No horizontal asymptote, right? How many of you got all 3 of those correct? All.
Oh, I didn't get one. Just kidding.
But do you understand what you did? Okay, so here's what I want you to do, okay? We're gonna have to continue with this, folks. The test might be put off until you get back. It might be put off until next Tuesday, because that would at least give us,
A test on January the 8th, 10th, somewhere. in
Let's
there.
not do that.
Oh, Miss
I
Furry.
think you want the whole year.
I don't want to play ball this weekend
Oh, I didn't
because
think.
it's going to be too cold.
Exactly, so January 8th will not be in this class after this break.
Jesus, take the wheel. My dad sings that song. I'm just kidding.
That way you don't just get dead.
What are we doing this morning? She told me not to tell y'all. It's okay. No, it's not anything that we're doing in class. It's because we didn't get any.
and no, I don't tell them.
She's calling on Friday.
Yeah,
Yeah, that's essays.
Well, she took pictures of it.
What are you doing?
I saw that. That's it.
She got kind of salty with our class because we didn't want to turn in our corrections. But you're doing a group work, like your support group with dictions and code. And then tomorrow we're doing all day on our projects. And she said she was going to be up on it. Yeah.
Oh, that's dirty. Put it close after one. Put it close after that. You got my pizza.
No.
Yeah.
What name?
I might change it.
Like, where can I take?
You know,
Of
some
yourself?
Yeah,
No,
I
like,
can get those. My phone is like. I got it.
Can you find me?
Yes, man, that's the right. I don't have any numbers.
So you bought a new phone and they didn't even have?
They gave it.
I quit. Oh, I took all the first one out.
So don't do it.
Don't do the first part, do the second part.
Who did the first one for extra credit?
No, we might tackle that tomorrow, okay? I only want you to look at page 245, and I want you to do 1 through 4, 13, 15, 19, 21 through 23.
The camera's deleted. We can find it.
What?
Yeah, like it's weird.
Look and see if we can, we'll take a look. If you look in the books, your book's here. It's just somewhere.
Why is it taking like
I don't know, take it with you.
But someone's up.
Or you can be like,
Just take it with you all the time. Okay? Folks, here's what I need you to do. Please pay, I'm looking at you.
No, that's
Bird man.
I'll do that every 5 seconds.
No, would you please listen? Okay, thank you. Time out, stop. Sandy's, y'all just keep aware of what's on the website, okay? We may take the test on Friday, we may wait till Tuesday. Either way, you have to take it next week anyway, okay? So it just depends. Everybody come in here, if you owe me that assignment,
I got you.
then it's due tomorrow, no excuses.
Gotcha.
Make me, if I'll put in 2 zeros if you want me to.